Okay, now members, we have seen how to get the shortest distance using the vector method, using the differential method. Now let us see the geometry method. Okay, hope you draw this diagram that we drew, and always this is our shortest distance. All we always need the distance between A and B, and then we need also the relative velocity of A relative to B. Of course, we shall get using this idea here. Okay, and then the distance is going to be this, and we say if this is sine alpha, you can see that this is going to be sine alpha is equal to the opposite, which is the over the adjacent, which is the cos multiply, you get that. Then our time it is going to be AB cos alpha, as simple as that. Or we can get also is that our AB cos alpha, this is our AB cos alpha, where is our alpha there. Okay, so over the relative velocity of A relative to B. All we need is this. Okay, so from there you can say that ship A is traveling at 30.23 kilometers on a course of 0.60 degrees. So we first put our A here. This is our A. It's traveling on a course of 60 degrees, and then it's using a speed of 30.3 kilometers per hour. Okay, and ship B is traveling at 20 kilometers per hour on the course. So this is our A. Then let us have our B here. This is going to be our B. Sorry, let me put it a little bit out. So this is our ship B. It's traveling at a course of 30, to break itself, a course of 30. So this is 30 degrees at 20 kilometers per hour. Okay. Due east 30 kilometers per hour. At noon, B is 20 kilometers due east of A. So meaning this A and B, they are 20 kilometers. So here they are 200 kilometers due east of A. Due east of A at noon. Okay. So we need our A relative, the rest of A relative to that of B. But you know that whenever we have A with B, get the velocity of A, then minus velocity of B. So let us come to this and see. To get this now, because our angle is with the vertical, so we shall move like this, we resolve this, and then we shall move in that order. So this is an adjacent, so this would be 30√3 cos 60 degrees, then this would be 30√3 sine 60 degrees. And so therefore, my velocity of A, the the horizontal component is going in the positive, so it's 30√3 sine 60 degrees. Then the vertical component is going in the positive, so it's 30√3 cos 60 degrees. Okay, so I have the velocity of A. Let me come to the velocity of B. I also move like this because my angle is here, so move like this in a vertical. Then it shall also move like this horizontally. So because this is adjacent, it will be 20. Then cos, because cos goes with adjacent, then this will be 20 sine 30 degrees. So meaning now, my velocity of B will be, see the horizontal component is 20 sine 30 degrees, then the vertical component is 20 cos 30 degrees. So this is our velocity of this first particle here in kilometers per hour, and then this one is also kilometers per hour. So to get this, now you can every substitute. This is going to be now the velocity of A, which is 30√3 sine 60 then 30 root 3 cos 60 degrees, then plus, minus, this is the minus the velocity of B, which is 20 sine 30 degrees, then 20 cos 30 degrees. Okay, so from there, we can simply simplify and get our A relative to B. Okay, you can see that this one, okay, we can then simplify that as 30 root 3 times root 3 over 2, then 30 root 3 times a half, then minus 20 times a half, then 20 times root 3 over 2. So that's how we can ever simplify. So by this one, by this is going to be 15. So this one is going to give us, this is going to be now 15 times 3. Okay. We are going to be adding now our A. Our A relative to B as, this is going to be 15. This time, this, that is 3, so that's 45. It's going to be 45. Then this is going to be 15 root 3. Then minus, this is going to be 10. And then this is going to be 10 root 3, which is going to be, so this one is going to be 35. Then this is going to be 5 root 3. That is our relative velocity in kilometers per hour. So we can maybe sketch it is that all of them are positives. So we are interested. So this is going to be 5 root 3. Then this is going to be 35. Okay. Now when we look at this, the angle we want is the angle to the horizontal. So we want to get this angle to the horizontal. So meaning, this is my A of B. I want this angle to the horizontal, which I'm going to call alpha. So you can set from there, you can set my alpha. Okay. My alpha is going to be tan inverse of, you see this is going to be the opposite, which is this 5 root 3. The opposite over adjacent, which is 35. So we get our alpha here. Then also get our magnitude of B, which is going to be the square root of, we get 35 squared, then plus 5 root 3, the whole square. Okay, from here, let me get my calculator first. Okay, so when I press this, I get 13.9 degrees. So let us see what we get in here. So here we shall get our AVB as 5 squared plus so it will give us root of this, which we can every give as 10 root 13 kilometers per hour. So we have our AB. So meaning, so now if I'm to draw now this diagram here, you can able see I have this. I also have this. I want this shortest distance D. This is always perpendicular. So this is our D we are interested in. So it's that this one I have it as A, B, which is 10 root 13 kilometers per hour. This is my A, B. The distance here is 260 kilometers. And this alpha, which is according to 13.9 degrees. Always when we are getting this, get this angle to the horizontal, because that's always what we want. Okay, so how do I get this distance? D. You can see that I have this, and then I have this distance and this. So if you can see that I have the opposite over the hypotenuse. So my sine 13.9 is equal to the opposite over 260. So my B will be 260 times sine of 13.9. And so my B is going to be it's giving me 62.4593 kilometers. That's the shortest distance. Okay, then time taken. This is my part A, the distance. Then part B, they want me to get the time. Now, what we can do, if we call this one maybe C, this time, it means that the velocity we are going to use, you can either get AC over this, or you can get using our formula. So, if we first use our AB cos alpha over ABB, because if you don't have this, you can start, if you have this AC, remember, which will be equal to AC over ABB. The time that it requires to reach this distance is going to be the distance this and the rest we are using, which is this. But now, you see, if you don't have this, you can use this. So mine is going to be my AB, which is 260, then cos of 13.9 degrees, over 10 root 13. So my T from there is going to be 260 divided by 10. So it's giving me, to 4 decimal places, it's giving me 7. It's giving me 7.0. Of course, this is going to be now as simple as that. So, that's how we use the geometry. If you want now to get AC, you can only get AC because you have this, you have also this, you can every get that. That's another alternative. Because it's that our AC, if you get your cos alpha, is going to be the adjacent over the hypotenuse. And if you make AC the subject, that's what you end up with. So, that's how we handle that, members. I wish you well. So now this is the geometry approach of finding the shortest distance. That's it. I wish you well.